Hey everybody. This is your buddy here, Nick, from the Polka Posse, down in the basement.
Yeah.
We got some other people in the house. Let's hear. Let's hear. Okay. Yosef's being quiet. Okay. Anyway, I'm here to talk about the affordable housing app and specifically how the API works. So what we are looking at right here is the form, and I think I can show you real quick. Run it locally. Hopefully I don't have a weird website up. Oh no, I didn't mean to do that. Oh, this is embarrassing. No route matches. No, I didn't. Oh, there we go. So what we have here is it's called Neighbor Home. Unofficially, it is the affordable housing app, and we have a map here, which is pretty cool. You can zoom in and zoom out, see the neighborhoods of Denver, and over here you can put in addresses. And so let's leave 1510 Blake. Let's say Coors and then what's like another vague address? I wonder what REI. You think? Oh yeah, let's try that. Let's see what happens. And let's say we're traveling by bicycle. What will it return? Oh, this is embarrassing. I wonder if that is because of REI. Try Denver Art Museum. Yeah, so it must not have liked REI. Although I think you are able to search by businesses and stuff like that. But what we are returning here is the top three neighborhoods that would give us the best average travel time for these three addresses. And now let's hop into some code. This is the form, like I said, that we're using to send information to our controller. So once you hit submit here, you are sent over to the create action. And what we're going to do is we're going to call on this class, the neighborhood analyst class, and call on the method top three neighborhoods. And we're going to send along the params. Now, for those of you who don't know what params are, we are going to check that out right now. Oh. So again, I'll do these addresses. I'll just search and hopefully we hit the pry, which we do. And you can see what the params are coming in. So we're sending in an authenticity token, the three addresses, our max price, which is going to be a future feature. And I thought there was something else. I thought it was supposed to be mode of transportation. Oh, that's because I didn't click it. So if I were to exit that, if I were to, I wonder why that happened. Let me exit. Did I hit it? But I hit it again. Yeah, that's what I'm gonna do. So let me spin this back up, and I will click bicycle here. Find me some neighborhoods, and what do we have in our params? Oh, we have transportation, bicycle. So essentially, the params are the information that you're trying to send, and like the information that you're trying to send to get other information. That's not really a good way to explain params, but anyway, moving forward. More code. So from here, we are going to the neighborhood analyst class, which we are first creating a new instance of the Google service, and then we're taking each address and we are creating a record of it for future for future queries. We're bringing the three addresses together. We are grabbing all of our neighborhoods. So what we have here is this is just okay. I forget how many neighborhoods are in Denver. I think it's like 40 or 47. So all this is here is 47 records of latitude and longitude coordinates. So these are the center points of all the neighborhoods in Denver. So we're taking all the neighborhoods and we are going. First, what we're going to do here, it's a little bit clunky, but what we're doing here is we're trying to find the distances between the addresses, the three addresses going in, and all the neighborhoods in Denver. And I'll walk through that. So we are first mapping through all the three addresses. So for each address, we are mapping over every neighborhood. And then for every neighborhood, first we're going to grab the coordinates from the neighborhood object. And then we are using a gem called haversine.
Wait, so how did you get the neighborhood coordinate information? It didn't say neighborhood coordinates at all.
Oh, yeah. So we set that up manually, essentially. We went through Google. We found like each neighborhood, and then we like essentially manually like clicked in the center of each neighborhood and got that latitude, longitude, and then stored it in the database. Yeah. So we're using a gem called haversine. Is it haversine or haversine? Yeah, let's say haversine. San. And what we're doing, haversinu.
Yeah.
Yeah.
That
Yeah.
sounds right.
Yeah, that sounds accurate. So what we're doing is we are finding the distance between the address, latitude, longitude, and the neighborhood, latitude, longitude, and then we are switching it to miles. So this right here brings us all of the distances between each address and each neighborhood. Then we are mapping through all neighborhoods and just getting the names, looks like. All neighborhoods map. Yeah, it looks like we're just grabbing the neighborhood names. And then, oh yeah, this is where it gets a little bit tricky. Because then we are zipping all of the values. What are we doing here?
Maybe like big picture, what is this class?
Oh, I know what we're doing here. So, I'm sorry?
Like big picture, what is this class responsible for?
This class is responsible for analyzing the neighborhood data, and like I said, this needs to be refactored, but it's like sort of the best we have right now. I want to explain the reason we even have all this logic here is because we want to figure out where the closest neighborhoods are to our addresses before we send API calls to Google. Because I think we were doing 150 API calls per submission, and now that number's down to like 27, 30. Do you have another question?
Yeah, and then like, so when we say analyze the neighborhood, we are like basically like pinpoint the coordinates what you just said. And this like second section here, like line 18 on, what is that like section actually doing?
Yeah. So this part right here looks a little bit confusing, and I know what's going on now. What we're doing here is we are for each address that each submission address we have the distance for to each neighborhood from each address, and we have those, and we're zipping them together essentially. So then what we have here are arrays of three distances for each address against each neighborhood, and then we're mapping through it and adding up. Oh yeah, so we are adding up the distances within the array, and then we're essentially returning. We're going on the next line here. We're going to return the lowest distance to address to neighborhood ratio. We're going to return the top 5 lowest distance between the neighborhoods and and the address is coming in.
So you're doing you're triangulating distances at this
Essentially.
point, right? You have three points on a map, and you're finding what is closest to the center of that triangle, right? So you're collecting that information first and making sure you calculate. I don't know. I'm not sure I fully understand.
Yeah.
And then you're sending that final result to Google.
We're sort of doing
instead of doing like first distance send to Google, second distance send to Google, third distance send to Google.
Exactly.
Okay.
Yeah, exactly. So we're doing some internal logic before we send anything to Google.
Cool. Thanks.
And then that's essentially what we're doing here is we are returning the top 5 neighborhoods that are closest. And then we are sending them to a variable called results, and we're mapping through those results, and we are first grabbing the neighborhood names. Nay.
I think maybe like a good suggestion for factoring would be like pulling this out into methods.
Yeah.
Right, and then like clearly labeling them.
I think it's a good idea.
The triangulation part would be one.
I'm quite embarrassed to say that I wrote all this code, so.
I mean, it works, right?
I couldn't have written it.
That's what I keep saying. Is it works?
Yeah, that's cool.
Yeah.
But anyway.
I'm following what you're talking about right now, and I'm surprised that I'm understanding what you're saying.
Yeah, no.
Because I didn't understand anything a while ago, and now I get it. Yeah.
Yeah. I like to say it's very. Yeah, I don't know. We can work on this together, Marina.
Yeah, that'd be
Now it's on record that you are going to be helping me.
He's locking you down.
All right, cool. So anyway, what we're doing now is we are finding each neighborhood name, and then we are essentially, what are we doing? Oh no, we're bringing back each neighborhood here, and we're mapping over the addresses once again. So now we whittled it down to, I think, potentially 15 different neighborhoods, because we have the top 5 set of 3 neighborhoods, so we have a potential of 15, and we are doing something. Oh, this is where we're actually calling the API. So we are taking the address, latitude, and longitude for each address, and then we are sending it along with each neighborhood's coordinates, along with the transportation type, and then we are sending those 3 things to a method called distance, which lives in our Google service. And let's take a look at that. Now, what we are doing, we're taking in 2 locations. We are finding. So what we have here is we are essentially looking for a time distance, or an average travel time between the addresses and the neighborhoods. So we are sort of standardizing like what day of the week that we are looking for it, and we figured like a Tuesday morning, which I believe is what we have here. Tuesday morning seemed to be like a regular time where like the traffic should be somewhat the same, as opposed to like a weekend where there could be events, there could not be events. So we're looking every next Tuesday. Every time you look, it's like looking for the time of next Tuesday. And then we're essentially sending up. Oh, okay.
Sorry,
First off, let me go over this. I'm sorry.
What's the math over there on the right? The 60 times 14.
This right here.
Yeah.
So in seconds, I believe this is 8:30 in the morning. However many seconds this is, I believe is 14. Oh wait, no, this is 14. Maybe this is 2 in the afternoon. 60 times 14 plus 30. This might be 2:30 in the afternoon. I'm not 100% on this, but it's a certain syntax. You have to write it in seconds, and it's a little bit confusing. But that's essentially it. This is like the time of day in seconds, and I don't know if you can do quick math. It's like, I believe it's 2:30, because 14 would be military time for 1400 hours is 2 o'clock in the afternoon, right?
Yes.
All right, so that's what I think this is, unless I'm wrong.
And then with that time, you
hmm Yeah, we're sending this time along to the Google API. Now let's talk about that real quick. Up here, what I'm doing is we're initializing a new instance of Faraday, and we are sending it to this base um, address. And this is like the base address for the Google API as far as maps. Yeah. So this is where you would like the what do you call it? Oh, this is the URI, which is like the URL without like the slash, like the endpoint. We're setting up the endpoint here in our params. And what we're doing is we are taking this connection, which is this up here, and we're doing a GET request. And then in our params, we are sending the origin location, which is going to be our address, and then the destination address, which is going to be, in this case, the neighborhood. The mode of transportation is going to be whatever the user specified. The departure time is going to be that standardized next Tuesday at 2:30 in the afternoon time. Language, English, because I speak English. And this is where we put our API key. And notice it's wrapped up like this because it's an environment variable. And unless you have it locally, then you can't make these API calls. Or you could also set it to Heroku, but like unless you can't just clone it down and start making these API calls without your own API key. So that's that, and then we get a response. Let's actually take a look at what the response is. Sure. So the response comes back as a hash. Aha. We come back with our destination address, our origin address, the distance in kilometers, and then the value. It's like the integer value of kilometers, and then the duration, which is actually what we're grabbing, which is in this case it's 13 minutes, or a value of I guess this would be how many seconds that would be. Status okay. So I'm imagining the status has come back okay because it was a successful call to an API. If you sent it corrupt information or wrong information, you might get something else back. And if I hit exit, it'll keep hitting it because it's in that loop. Let's get out of that right now. So what we're doing, in order to get that duration time, we are traversing the hash tree, like I was saying. Is we're first looking to the key rows, and we're taking the first element, and then we're going to the key elements, and we're taking the first element within there. And then again, we're looking to duration, and we're taking that value. So now, this value, I believe, is the integer value. So now we have the integer value of how many seconds it's going to take to go from that address to the neighborhood, and then that information comes back. That information gets mapped together. All the values are going to be mapped together, and then we are going to again map through that array and add up the results within each array. So now what we have is an array of arrays, and each of those nested arrays has 3 elements, which are the integer value of how many seconds it would take you to travel from each address to location. And again, we are just reducing that number, so adding it up, dividing it by 180, and not sure why we're doing this. If you took second, so I guess if you took seconds and divided it by 180, would that give you hours? Would that give you minutes? I'm not sure. Unclear on what this 180 is doing, but not important. We are returning the top 3 results of like the closest neighborhoods to your addresses, and then that is essentially what we're doing. Is we are returning the top 3 results, or top 3 neighborhoods, and then we are sending it to the index, just like. Let me make sure I got all the prize. I got all the prize out of here, right? Yeah. So just like. Just like that.
That's what we were saying.
And this is what we were returning. We're returning the title of the neighborhood and the average time it would take you to travel from your addresses to these neighborhoods. And this should give you at least a good idea of like what are the closest neighborhoods to the addresses that might be the most important to you. And I think that's about it for this episode. Oh no.
We're lost.
All right, signing off. This is your pal, Nikki No Naps, Polka Posse for life. See you later.